In this projectile motion problem, we need to find the initial velocity of the ball when it was left from the hand of the player and the final velocity of the ball when it is entering into the basket. So we'll read the question and see what is given and what is required. A basketball player attempts to make a basket from a distance of 10 meters. So what this means, the distance from this 10 meters distance is the distance between the player and the basket. So this is a 10 meters. The basket is 5 meters high, so it means that delta h, we can say the height is 5 meters, and the ball leaves his hand from the height of 1.5 meters. So this means the height 1.5 is this height we have. .5, so we'll say this height we can say del y naught. If he throws the ball at an angle of 47 degrees, so what this means that when it is thrown with the initial velocity, it is making an angle of 47 degrees. So this is our initial velocity, and this must be the x component of the initial velocity. So we'll say vi x equals to vi cos of 47 degrees, and this one will be viy equals to vi sine of 47 degrees. So we have resolved this initial velocity into its components. So the value of the x component of the initial velocity, which is vix, we can say this is equals to 0.68, which is the value of cos 47, and then we say vi. So we have this information, and the y component of the initial velocity, which is viy, that will be 0.73 vi. So this is the information we have for the initial and x component of the initial velocity and the y component of the initial velocity. So we need to use an equation, kinematic equation, delta x equals to x naught plus vixt plus 1 by 2 gx t square. So what is x naught? As we know, the x component of the initial velocity we have already. The time we need to calculate that. But gx, what should be the value of the gx? So in the x direction, the velocity is constant. So this means that the acceleration due to gravity in the x direction is 0. So this will make this equation to x, this will be turned into, this will be 0 because gx is 0, and then we have vixt. And what is x naught? X naught is a point where this player is standing initially, x naught. So this value is 0 because this person is at its reference point where this player is not moving, he's standing. So we'll put x naught equals to 0. So our equation will be delta x equals to vix times t. So this is an equation which we are going to use it. So we know the value of the x component of the initial velocity, Vix. This is equals to 0.68 Vi. So we will use this equation. Let's say we say this equation A, and we are substituting the x component of the initial velocity into equation A. So delta x, we have an information for this already. So which means delta x is our this distance. Delta x is our 10 meters. So we are using this equation Vix times t. So 10 equals to the x component of the initial velocity is 0.68 Vi times t. So if we divide at both sides by 0.68 Vi, this will be cancelled, and the value of t we will have 10 over 0.68 Vi. So this is the value of t. But the thing is that we cannot calculate the time as long as we have no information, or we haven't calculated the initial velocity. First of all, we'll calculate the initial velocity by plugging this value of t into another kinematic equation in the y direction, y naught plus initial y component of the initial velocity times t plus 1 by 2 the acceleration due to gravity in the y direction, t square. So y naught is this height we have. This is our height, y naught, 1.5 meters. So we will use this 1.5, and delta y is the height of the basket, which is 5 meters, which we will plug it here. And the initial velocity, y component of the initial velocity is 0.73 Vi, and then we will plug the value of time, which is 10 over 0.68 Vi plus 1 by 2. The value of g in the y direction is negative 9.8 meters per second square, and the time we have is 10 over 0.68 Vi, and then we'll take the square of it. So we can clearly see that we can cancel Vi with a Vi. Now we will solve this equation mathematically. So it will be 5 minus 1.5, that is equals to so 10 multiplied by 0.7 will come up to 10 times 0.73 divided by 0.68. So that will come up to 10.73. And then we have this 2 is dividing this 9.8 will come 4.9. So it's negative 4.9. So negative 4.9 we have, which is negative 490 over square of 0.68. When you take this, it will be 0.46, and then we have a square of initial velocity, so that will be Vi square. So 5 minus 1.5 will be 3.5 equals to, no, we can say that we can move this we can move this 10 to the left side, 10.73 to the left side of an equation, and at the right side we will have 490 divided by 0.46 vi square. So this equation will be reduced into negative 7.23 equals to negative 490 divided by 0.46. So we'll isolate vi square. That will be negative, will be cancelled with the negative. So it is 490 divided by 7.23 times 0.46, which is equals to 147.36. So if we take the square root at both sides of vi square, that will be 147.36. So this will come up to 12 meters per second. So this is the initial velocity we have calculated of the ball when it was left from the hands of a player. So 12 meters per second. So we have calculated the initial velocity. Now we need to calculate the final velocity when the object is entering into the basket. What this means, that if this is a basket and let's say this is the final velocity we have. So final velocity when it is entering into the basket. So what we need to do is we again need to resolve this final velocity into its components. So this is the y component of the final velocity, Vfy, and this is the x component of the final velocity, Vfx. So as we know that the x component, the velocity in the x direction is same. So if we know the x component of the initial velocity, it will be the same for the x component of the final velocity. So we have Vfx will be the same what we have for the initial velocity. So the initial velocity we have calculated as that is 0.68, and the initial velocity we have calculated 12 meters per second. So the x component of the final velocity we have, is 8.18. So we have this information. So what we are going to do, we need to calculate still the y component of the final velocity. We have this information, but still we need to calculate the y component of the final velocity. So for this purpose, we'll say Vf equals to Vi plus Gt, and we will put y here because we are calculating in the y direction. So we have, now here is the point to understand, that for the initial velocity or in the y direction we have was Viy. So Viy equals to, that was 0.73 times 12 meters per second. So that will be 8.18, and the value of the acceleration due to gravity is negative 9.8. And now here is the thing we need to understand, that we need to calculate the time. So how we'll do that? That's very simple. We already know the delta x equals to 8.18 times t. which means that delta x was this. Delta x equals to Vix times t. So x component of the initial velocity, we have calculated this. So that will be delta x equals to, so delta x we have 10 equals to 8.18 t. So we'll divide 8.18, 8.18, 8.18 at both sides. So time we have 1.22. So we will plug this value here, 1.22. It's 9.8 and 1.22. So we are coming up with the final velocity, y component of the final velocity. That is the y component of the initial velocity we have calculated, 8.18. When we multiply negative 9.8 with 1.22, we'll come up with 11.95, and that will be the y component of the final velocity we will calculate is negative 3.77. So as it is that as this the y component of the final velocity is pointing downwards, that's why it's negative. So now we have the information for the y component of the final velocity, and we have the value for the x component of the final velocity. So we have these two informations. So we can apply the Pythagorean theorem to calculate the final velocity. So that will be negative 3.77 square plus 8.18 square. So that will come up to square root of 81.12. So we'll put a square root here to get rid of this 2. So the final velocity we will have will be 9.006 meters per second. And the initial velocity we have calculated was 12 meters per second.